We're going to look at solving a problem involving the pH of a weak acid solution given just the Ka and the molarity. Remember that we don't have to do very much if this had been a strong acid. Remember the strong acids, everyone has their own list, but this is the one that we use: hydrochloric, hydrobromic, hydriodic, nitric, sulfuric, the first hydrogen only, and perchloric acids. For those, we don't need a Rice table. We can just assume that they dissociate 100%. Although you can use a Rice table, and that's a perfectly good way to solve them, but just remember that they dissociate 100%. Here we have a weak acid with a Ka that's relatively small, and so we're going to use our usual Rice methods for doing the math. So we set up our Rice table: reaction, initial, change, equilibrium. First, we have to come up with a reaction. Oftentimes that's given to you, but all it is the dissociation of the acid. Hydrofluoric, remember hydro just means an H with a monatomic anion. There's no polyatomic anion back here. So that's hydrofluoric acid, and we're going to write it dissociating this way. You're going to see other things on the internet with this reacting with water and forming an H3O plus ion here. I prefer to do it this way. Either way is fine. So now we have our reaction. Now initially all we have is 0.5 molar hydrofluoric, 0.1 molar hydrofluoric. So that goes here. We have no H plus, we have no F minus initially in this problem. So our change, this reaction has to go in the forward direction. There's no products initially. So this will be minus X on the reactant side and plus X on the product side. Remember, those are all 1 to 1 to 1 because the reaction coefficients are 1 to 1 to 1. And then to get the initial plus change gives us our equilibrium. 0 plus X is X, 0 plus X is X. Now we need an equilibrium expression. So our equilibrium expression, remember, is Ka. It's A for acid here because we're producing H plus ions. Also, it's an acid. That's the other way to remember that. So the Ka here is going to be products, H plus concentration times F minus concentration over the concentration of HF, the associated acid. And now we're going to take our equilibrium row of our Rice table and plug it into our equilibrium expression. All right, so that's going to be X times X over 0.10 minus X, all of which is equal to our Ka value of 3.5 times 10 to the minus 4. Because that Ka value is pretty small, it's less than 10 to the minus 3, we're going to go ahead and assume that these X's that are added and subtracted are small enough to neglect. So we're going to neglect that guy. And then we'll come over here, finish up the math. So simplifying, up top we've got X squared. That's over 0.10. And that's all equal to 3.5 times 10 to the minus 4. Now we're going to multiply both sides by the 0.10, or you can think of it as cross multiplication, whatever one makes more sense to you. So now we have X squared equals 3.5 times 10 to the minus 5. If that's not comfortable doing that in your head, feel free to use your calculator. Square root both sides here. Break out our calculator. This part I definitely can't do in my head. Square root 3.5 times 10 to the minus 5. Remember, on your calculators, a lot of them have a different number or a different key for the negative sign versus the minus sign. I tend to say minus, but what I really mean is negative. So make sure you're using the right key there. All right, and we get an X value here of 0.0059. All right, and now we got to actually ask ourselves, what were we actually being asked to solve for? We need to find the pH of the solution. The X value we get here is our H plus ion concentration, so we're almost there, but we've got to change it to pH. So we remember that pH is defined as, under normal circumstances, is defined as the negative log of the hydrogen ion concentration. All right, so now we're just going to take the negative log of this value, and that's going to give us the pH. All right, negative log, and that's going to give us a pH of 2.2. All right. So when you're solving a problem involving a weak acid solution, we're always going to use a Rice table to generate our variables to plug into our equilibrium expression, do the math. Remember at the end not to just stop at x, but to actually answer the question and find the pH.